Bismillahirrahmanirrahim. Assalamu alaikum students. I am Ms. Nafisa Kawal from Hamza Army Public School and College, Boys. This is your chemistry class, chapter number 6, solutions. This is week 10 topics which you have already discussed of chapter number 6. It includes concentration units and different types of the concentration units. You have discussed in the last lecture that what are the concentration units and what are the types of the concentration units. These are the two different types of the concentration units, percentage and molarity, which is given in your book, and we have discussed these two types of concentration units in detail. The percentage concentration unit you have already discussed in the last lecture in detail. Today inshallah we will discuss the next concentration unit, that is the molarity, and we will discuss different types of the different examples of the molarity. Okay, now I will give you a brief overview that what you have discussed in the last lecture. You have discussed the 4 different ways to express the percentage of the solutions. Now what are these 4 different ways? Let's have a look. These are the 4 different types of the percentage concentration unit. The first is mass by mass percent, M by M, mass by volume percent, this is M by V, volume by mass percent, this is V by M, and volume by volume percent, this is V by V. So these are the 4 types of percentage units which you have already discussed in your last lecture. Today we will discuss in detail about the molarity. These are the objectives of the today's lecture. At the end of the lecture you will be able to define the term molarity, and you are able to explain the different examples of the molarity, and you are able to solve different numericals related to the molarity. Okay, now we will start our topic, that is molarity. First of all, we will discuss the definition of the molarity. Now what is actually molarity? We have already discussed that molarity is the type of the concentration unit. Now in which amount of solute, now amount of solute we have to take in unit moles, and the quantity of solution we have to take in dm cube, or we can say decimeter cube. Amount of solute in molarity we have to take it in moles. Now what is mole? It is actually mass divided by the molar mass, and the solution, the volume of the solution, we have to take it in decimeter cube. Now molarity is defined as number of moles of solute dissolved per dm cube of the solution. How many number of moles are present per dm cube of solution, that is actually the term molarity. Okay, now we will represent this molarity by the capital M. Now what are the unit of molarity? The unit of molarity is mole per dm cube. Mole per dm cube. Dm cube is decimeter cube. Okay, now the formula of molarity. These are the 2 formulas of the molarity which is given to you here. Now molarity is mass of solute divided by molar mass of solute into 1 divided by volume of solution in dm cube. Okay, now mass of solute divided by molar mass of solute, you can also replace this mass of solute divided by molar mass of solute by the term moles of the solute, because we know that moles of the solute is actually equal to the mass of solute divided by the molar mass of the solute. Okay, now if the volume of the solution is in dm cube, you can put 1 over here. Okay, now if you will see the next formula, that molarity is mass of solute divided by the molar mass of solute, multiply by 1000 divided by volume of solution in centimeter cube. If the volume of the solution in question it is given to you in centimeter cube, you will directly put the value of volume of solution here, but you have to add this 1000 over here to convert it into the decimeter cube. If the volume of the solution in question it is given in the decimeter cube, then there is no need to put 1000 over here. Okay, now I will explain you the another formula of the molarity, that if you will substitute mass over molar mass with moles, then what will be the formula of the molarity? You can see here that molarity, this is molarity is equal to now what we have to do, mass of solute divided by molar mass, we have to substitute it with the moles of solute, moles, you can see moles of solute like this. You can use both formulas. If the moles are given to you in any question, then you can use this formula, that moles of solute divided by volume of solution in dm cube, right? If in question the mass is given to you, then what you have to do, you have to use this formula of the molarity. Okay, if mass is given, first of all you have to calculate molar mass, then put the values in this formula, then you got the molarity of a specific solution. Is it clear to you? Okay, the next, here is a diagram to show you that how we are able to prepare the solution of a specific molarity. This is the volumetric flask. What you have to do, add the solid. Say for example, if we want to prepare 0.1 molar NaOH solution, you have to add NaOH solution in it, add water in it. Now what you have to do, dissolve this solid into the liquid water. After the dissolution, what you have to do, fill that volumetric flask up to the mark to make that specific solution of the specific molarity. Now the explanation of the molarity. For example, I'm going to say that I have to prepare 0.1 molar H2SO4 by mass and 18 molar H2SO4. What does it mean by this statement? Volumetric flasks. If you read the label on this bottle of the concentrated sulfuric acid, it's written over here that it is 98% pure and 18 molar H2SO4. 98% H2SO4, you have already discussed the percentage concentration unit. According to that, 98% H2SO4 means that 98 gram H2SO4 is dissolved to make a solution of 100 gram of solution. Now what does it mean by 18 molar H2SO4? It means that 18 moles of H2SO4 is present in each dm cube, or you can say that 1 dm cube of the H2SO4 solution contain 18 moles of the H2SO4. Now we will discuss one more example to explain the concept of molarity, that is that 37% HCl by mass and 12.1 molar HCl. Again, here is a concentrated H2SO4 solution. If you will see, it's written over here that this is 37% HCl by mass. What does it mean? That 37 gram of HCl is present in 100 gram of the solution, and 12.1 molar HCl means that 12.1 moles of HCl are present in each dm cube of the solution. Okay, now we will discuss one example of the molarity. This is a question. I am going to read it and then we will solve it. Urea NH2CO NH2 is a white solid used as a fertilizer and a starting material for synthetic plastics. A solution contains 40 gram of urea. This is the mass of solute in 500 centimeter cube of solution. This is the volume of the solution. What you have to do, you have to calculate the molarity of this solution. Okay, now this is the solution. Look at here, the mass of urea is 40 grams. Molar, first of all, you have to calculate the molar mass because mass is given over here. Nitrogen, atomic mass is 14 plus 1 is the atomic mass of hydrogen, multiply by 2 because there is 2 hydrogen over here, okay, then plus carbon 12 atomic mass plus 16 plus 14 plus 1 into 2. The answer you got is 60 gram per mole. Okay, now we have to calculate first of all the moles because we are using the formula of molarity, moles of solute divided by dm cube of solution. Moles of urea, mass divided by molar mass. 40 divided by 60, you got 0.667 moles. Now the volume of solution in question is given in centimeter cube, and in formula we want to convert it in dm cube. What you have to do, divide this 500 with 1000, then you got 0.5 dm cube. Put the values that molarity is equal to 0.667 divided by 0.5, then you got the answer that 1.334 and the unit is capital M. So this is the molarity of this urea, 1.334.